Alright, so in this section we'll be looking at and working with Git, which is extremely popular in web and software development. It's a version control system, also known as a VCS, and it's used in software development as well as other version control tasks, and it's essentially a tool to manage source code. It's aimed at speed, data integrity, and support for nonlinear workflows. It was created by Linus Torvalds in 2005, and that name may sound familiar because he's also the one that created the Linux operating system. So every Git directory on a computer is essentially a full-fledged repository, also called a repo. Now, a repo or a repository is an on-disk structure which stores metadata for a set of files or a directory structure. And some of the metadata that a repository may include is a history of changes, a set of compiled objects, and a set of references to commit objects. The main purpose of a repository is not just to hold current data, but all of the changes that data has gone through. Alright, so we should be able to go back to any point in time in the development process as long as that point was committed, of course. So what are the benefits of using something like Git? It does add a couple extra steps to your workflow, and most of us like to keep that as simple as possible. But when you look at it, the work that you put in for version control can be well worth it, especially on big projects with multiple developers. So first and foremost, it gives you an easy way to back up your work, and not just save your files, but save all the versions of your files. Alright, so you can create commits at any point in your development, and you can easily go back when and if you need to. Git also allows you to work offline more efficiently. So some version control systems have a centralized repository that you'll push and pull from, but Git gives you your very own local repository to work with, whether you're connected to a network or not. Alright, so you can work offline much more efficiently. And we also have branching, which allows you to have individual lines of development, which I'll get to in a minute. Collaboration with other developers is easy because they can work on their own branch or version of the project, leaving the main code base intact. Alright, so when you're doing things like moving or adding files, it's really easy, and Git tracks all your movements, so you always know where everything is at all times. So let's talk a little bit about branching. Okay, branching is one of Git's best features. A branch essentially represents an individual line of development. So instead of having this one code base that multiple people can edit and you have the huge possibility of someone messing up, developers can have their own branch. Alright, or you may have multiple branches dedicated to multiple features or functionality. Okay, so you might have an e-commerce application and then have a single branch where you're developing a user login and authentication system. So you don't want a half-working login system on the main branch, so you develop that separately and then merge it when it's completed or ready for testing. So branching serves as an abstraction for the edit stage commit process, and branches can be merged with the master branch at any time. So if we look at this diagram down here, we have 4 different branches which all represent isolated lines of development. Okay, we have this master branch, we have a development branch, and then we have 2 branches for 2 separate features. Alright, and they can all be worked on in parallel, and the main branch isn't touched at all until the other ones merge onto it. Alright, so you can see we also have the versions here of the application. So we have version 0.1 where it started a development branch and we moved along. Version 0.2, they decided to add a new feature, so we added another feature branch here. Alright, version 0.1, you had another feature, and it can go on and on. Alright, so it may sound a little confusing, but we'll get into this later on. So here is a set of the most common Git commands and commands that we'll be working with. So git init will create a local repository. It'll create a .git folder, and that's where it'll store all the information, all the repository data, all the metadata, the versions, everything. Alright, if you delete that .git file, you're going to delete your repository. Git add will add a file to the index, or basically the staging area. Alright, so git add and then the file name. You can use git add dot, and that will add everything that's in that current folder. All right, git rm will remove it from the index. Git status will get a summary of the staged files, so you know what files are ready to be committed. And then of course we have git commit, which will record changes to the repo. This also takes a log message. For instance, if it's your first commit, you might want to write that as a log, that it's the initial commit. Git clone will clone a repository to your machine. You just want to add the path to the repo. This can be a remote repository from something like GitHub. Git push origin master will push to the remote repository to the master branch. Git checkout -b branch name. So this will create a new branch and switch to it. If you leave out the -b, that'll just switch to a branch that already exists. Git merge branch name will merge a different branch into the active one, okay, whatever one you're in. And then these two git config commands down here, this is to configure your name to use with commits, and this will configure your email. Alright, so these are just some of the more used commands in Git, and we're going to get to all of these later on. Alright, so that's a brief summary of what Git is all about. Hopefully that wasn't too confusing. If you don't have any experience with this, we're going to take it slow, and in the next video we'll go ahead and install it and get set up and start to look at some of the commands.